Alrighty, so fill in the table. This is just qualitatively. Is it positive, negative, or 0? Okay, so 3 seconds is right here. Okay, so look at that. We're right at a peak there. So that's, one of these crucial times here. Okay, I can say at 3 seconds that our x is positive. And that's easy. Positive x is up here. Negative x is down here. That's easy, right? Okay, so anything above 0 is going to be positive x. And then we're looking at the velocity there. Velocity is going to be the slope of this graph, okay? So the slope of this graph, this is positive velocity. This is 0 velocity. This is negative velocity, right? Positive, 0, negative, okay? And I think we've got a spot right here where it's the tangent line is level, right? So that's 0, okay? And then the acceleration, there's 2 ways to do the acceleration. Acceleration in general on any position time graph is the concavity. I don't even know if that's a word, okay? But it's the concaveness. Is it concave upward or concave downward, okay? These are examples of things that are concave upward. Notice that they smile at you, right? They're positive accelerations, okay? In general, by the way, the slope is becoming more positive, okay? Because the acceleration is the second derivative. It's the rate at which the velocity changes, right? So in calculus, that's our second derivative. So this is positive. It's becoming more positive, and this is because it's negative, and it's becoming less negative. Here it's going from negative to positive. That's a more positive change. Here it's going from not very much positive to a lot positive. Those are all positive changes, okay? Downwardly concave looks like this, right? Okay, this is negative concavity. And the way to think about it is you think of this as a cave, and if you can get to the cave from the top, it's positively concave. If you get to the cave from the bottom, it's negatively concave. Okay. In these cases, the slope of this is becoming more negative, from not very much negative to a lot negative, from positive to negative, and from very positive to less positive. Okay. So all of those are changes. These are negative changes. Okay. So let's take a look at this guy. This is clearly going from, at that point, it's in the process of going from positive to negative. So this is concave downward. Okay. Oh, the other way you can do it, you can just totally scam the acceleration. Okay. This is positive x and negative x, but anytime you're above the equilibrium point, right, or to the right of the equilibrium point, you're accelerating toward the equilibrium point. So this is negative acceleration. Anything above here is negative acceleration. This is positive acceleration. That takes a lot less energy, but this works, by the way, on any position time graph. Okay. That trick only works on simple harmonic motion. Okay, so let's look at 1.5 seconds. So 1.2, 1.4, 1.5 is a special case as well. Okay, so it's going right through the origin. So I believe that x is 0. Okay, what's our velocity? Well, that's a downward slope, so that's negative. Yeah, this slope here. It's one of these, right? Okay, let's see. And then the acceleration, well, if x is 0, then acceleration is 0, right? Because remember, acceleration is just the opposite of omega squared x. Okay, let's see. 2.4 seconds. 2.2, 2.4. There it is. Okay. Well, x looks to be about -1, right? So that's negative. Our velocity is, well, it's an upward slope there, right? That slope is positive. Okay, and then if we look at this thing, this is actually upwardly concave, okay? This stretch here, right? And by the way, these are inflection points here where the concavity changes. Okay, inflection points are to concavity as these maxima and minima are to slope. Okay. Okay, so this guy is going to be positive. Okay. Also, we're below the origin, so we're heading toward the origin, the equilibrium point. All right, 3.8, let's find that. 3.2, 3.4, 3.6, 3.8. Okay, again, I believe our x is negative. I think this is a place where it's upwardly concave, so this is positive. These, by the way, are just always opposite each other. Yeah, if this one's positive, that's negative. This is negative, that's positive. Okay, let's look at our velocity. I think that's a downward sloping line there. The tangent line would be negative. Okay. By the way, you know your calculator. If you put your calculator in radians, type in this formula, and you have no idea, it'll give you the correct sign. Your calculator knows. Okay, 4.5, is that this guy right there? I think so. That is, our x is 0, so is the acceleration, right? Because acceleration is just some constant times x. Okay, what's our velocity there? I think our velocity right there, 4.5, is positive, because and it's a maximum, by the way. It's a maximum slope right there. Positive slope. Okay, let's look at 4 seconds. And that's a special case too. We're right at that little peak there. So our x is a maximum negative, which makes our acceleration, of course, positive. Okay, because this is upwardly concave. Also because we're to the left of equilibrium or below equilibrium, and we'll be accelerating. You're always accelerating toward equilibrium. Okay, and then our velocity at that point is one of these guys, right? So it's going to be 0. All right, hope that wasn't too explainy.